And that piece is pencil. La pluma is pen. You will also see this for pen. El bolígrafo. Also see that. El marcador is marker. La ventana is window. La pared is wall. La puerta, la puerta, so make that L E. So la puerta is door. El cuarto is room. La mesa is table. La mochila is what is that? Book bag. Empaque. What does that look like? What do you guys write about? Paper. Empaque, paper. La computadora usa. La tarea is homework. Did you guys know? And that's a real law. It's not help. La lesión is lesson. La estudiante. We're going to say el estudiante for recall it. We'll say las estudiantes for evaluation and accent. So that is students. I do not like el mamel or la maestra, so we're going to change that to exclusive. That's easier. You'll also see profesora or profesor. And then L or la amiga or amigo is friend. And then el la compañera, the last is classmate. If you want to stop here, I am going to the quiz. I'm going to focus mostly on the front page, okay? If I were to say, when is Christmas? What's the date for Christmas, right? You would circle December 25th, and I would write it like how we learned how to write the date, right? And then December, then December, 25th of December, right? And I will probably do matching for these verbs. And probably a matching with the start. Okay, but study this, all right? And okay. And you have homework. Por favor. No, yeah, bring that back, we'll finish that next time. And we'll. Ben, hello. How are your knees? No. It's also really good. You want to first start to because there are a couple of things.
It's fun.
Yeah.
Yeah.
Because I'm circulation. He's making some like what things about. No, yeah. Oh, see, I know, yeah, 100%. Absolutely. 100%. Okay. No, it's hey. No, it's right, not wrong. Absolutely. No, no. It's not good.
Ladies, how are we? Well, you're not alone today. We have a new fellow who should be here like right at 10, who wants to give class a try and see if he likes it. His mom's gonna hang with him. His name's Levi. So he should be here in just a few minutes and he's gonna kind of get a feel for class. So I'll give you girls a second to get your binders open and your Rico's stored away where they go. And Evan is out of town. Evan is, I don't know where, out of town. When he'll be back. He told me last week, I think, but I don't remember. Did you have a good weekend? Do you speak? Yes, you had a good weekend. Cool. How'd it go? Yeah? Do you know yet? Post the list yet? He should say genius. That is cool. I like your shirt. That's very cool.
After we auditioned, everybody kept saying that I sounded like the blog.
Ooh, really? That's a compliment. Did you audition for a specific part or is it just a general audition?
Well, they have like songs like if you want to be Ariel, you have to do a song.
Mm-hmm.
If you want to be Ursula, you have to do a certain song.
Okay.
So like, you have to do that if you want.
Do that for that part. So did you audition for a particular part?
I auditioned for Ariel and Ursula.
I think you'd make a good Ursula, actually. I think you'd be. And how about you, Everly? What'd you audition for?
Ariel.
Did you just Ariel? You'd be a good Ariel. Will keep me posted if you guys make it. I would like to come see it if I can. So be sure to give me your show dates and times and all of that because I do like to come when I can. I think I figured out my Zoom. It failed me the last 2 times because it failed me at the Grill and Chill and then it failed me last week. But it seems to be working now. I don't know what happened to it. It's supposed to pop up and then give me the reminder. And then last week it recorded all of 13 seconds of a class. I'm like, that does me zero good. Why do I need 13 seconds of a class? So hopefully this week it seems to be going. It says it's recording and everything is rolling. So that's all a very good thing. Excellent. Good deal. Good deal. So you had your auditions and that was your weekend, huh? Yeah, that sounds good. That sounds very good. Well, Cole left on Sunday morning at like 4 a.m. to drive all the way back to Texas. And he made it by like, I want to say it was about 3:30 our time, maybe 4 our time. So he made really good time. He he was moving. So, but he's gone now, so he won't be back till November. Oh well. But he was ready to go. He was tired of being here with us. He actually went on Saturday. He moved Claire's brother into at Mercer. He was starting Mercer. So he went and helped Claire's family move Claire's brother into school. And then that was it. Then he left a couple hours after that in the middle of the night. You know why he's driving in the middle of the night? Because he has no air conditioning. Because if you drive with your windows down and your air pumping, puts a lot of strain on that compressor, and that's what he did. It died. So we actually fixed it once, but he didn't buy a new compressor. He bought a used part off of Facebook Marketplace with no warranty, and it died like 2 weeks after we paid to have it put in. So we're like, you're on your own, figure it out now. We told you to buy a new part and you didn't, so you figure it out. It's all a part of becoming a responsible adult. Let me see if we give them just a minute to get in the door and stuff before we start if that's okay. Is that cool? Yeah. New fellow. Yeah. Amira had a good time, but she just wasn't quite ready. So maybe we'll see her next year. But y'all will be done next year. Y'all will be in middle school next year? Yeah. Which middle school is it? Where? Vickery? Okay. Yeah. All right. Yeah, that makes sense. That'll be all next year. Are you excited about that? Mm-hmm. Are you gonna do any particular extracurriculars? Are you gonna do drama or chorus or? Sounds good. Chorus sounds good. I don't know anything about the chorus teacher at Vickery. I know the one at Hendrix is very, very good. She actually teaches sight reading and things, like for real. Because I have a friend whose daughter's in that. Actually, I'm going out to dinner with them tonight. She's been in that course for the past couple of years, and she's actually learning music. Come here, twinsy. Do y'all share a room? Yeah, I figured. Y'all are pretty tight. That's awesome. Let's see. Do you see that yet? Well, we'll go ahead and start anyway. And then when he comes, we'll pause and do introductions. Is that cool? All right, excellent. Okay. So I've graded everybody's tests. Everybody did pretty darn well. Very good. I'm happy with that. So we are into the school year proper now. We're out of unit 1. Unit 1's are how to do science class, basic science stuff, some real basic concepts, foundational business, right? And we are out of that now and into our second unit. Hi, come on in. Hey, I'm Danny.
Jenny.
You're Jenny.
Nice to meet
You Levi. Hi, nice to meet you. If you want, there's a spot right there. So we have one other dude in class, Evan, and he's just out of town today.
Okay.
So yeah. So it's Evan, and then this is Emerson Wave.
Hi.
Which one of you is Emerson? And then this is Everly.
Okay.
Yes. So this is Levi. So we were just getting started. I was just telling him I finished grading tests and everything. Our unit 1 is real. It's foundational. It's pretty quick, right, girls? It's really only like one lesson before class, like to kind of get everybody on the same level, and then one lesson about it was just basic biological chemistry.
Okay.
And then we move on. So now we're getting into like more our normal routine of things.
Okay.
So unit 1 is done. We are moving into unit 2, which is ecology. So what the girls have done over the last week is y'all read, right? You did your reading assignment, and then this is the binder assignment, and I want to.
Oh, right. Thank you.
Appreciate it. Yes, there you go. So they went through that before they came to class. And then what we're going to go over now will be what they've already read and filled in. So this is all kind of reinforcement of what they've done. And then girls, what happens when we come to one of those little boxes on the screen? What are those for? The
What?
little boxes. You have to answer the question. And if you get the question right, what do you get? A penny. And what do you do with the pennies? You use it for the Skittles machine at the door, and everybody has little cubbies here with their names on them, so I drop pennies in as we go. Yes, it works very well. It motivates people to speak, especially people that aren't very loquacious. Neither of these two are very chatty, are you? You're kind of quiet ladies in general.
We understand.
All right, so here we go. So unit 2 is ecology and the biosphere. So let's get started with this. So the first thing we're going to talk about is energy flow in systems. So we have, there's different ways to categorize organisms within an ecological system. One way is producers, consumers, and decomposers. So what do we call living things that make their own food? Who knows? Everly. Those are going to be our producers. And those are things where sunlight is their source of energy. So largely producers, we think of trees or algae, photosynthetic organisms, if sunlight is their source of energy. But as you'll learn as we go along, there are some organisms that don't use sunlight as their source of energy. They will use chemical energy. And those are typically organisms that live like very deep in the ocean where there is no sunlight. So those are also producers, but they're a different kind of producers. Generally speaking, we'll be talking about plants. And what are living things that require other living things as a food source? Emerson, do you know this one? What are living things that require other living things as a food source? Who knows? Emerson, what you got? Consumers. So consumers. So for example, these little frogs, little tree frogs. What do frogs eat? What do they eat? What do they eat? What do frogs eat? Do frogs eat seeds like birds? No. What do they eat? Bugs. Okay. So they eat other things, right? Now, at this level, your consumers can be herbivores, omnivores, or carnivores, right? Frogs are usually, what do you think? Herbivores, carnivores, omnivores. What do you think a frog is? Do they eat animals, plants, or both? You said they eat what? Bugs. So that would make them carnivores. Primarily. Yep, most frogs are going to be carnivores. Now we'll learn like carnivores, herbivores, omnivores, and there are certain animals that are like obligate carnivores, like they only eat meat, that's all they eat. But then there are other animals that are like predominantly carnivores, like dogs are a great example, but they're what we call opportunistic omnivores, because if you drop a marshmallow on the floor, your dog's going to eat it, right? So that's not necessarily meat, although it is derived in some ways because collagen is usually in it and gelatin, and that's going to come from like horse hooves and blah, blah, blah. But if I drop a strawberry on the floor, Ozzy's going to eat it. So although he's geared towards being a carnivore, he's an opportunistic omnivore. If the opportunity presents itself, he will eat that strawberry. And then what are these guys? The last ones. All right, Everly, you take this one. Decomposers. So these are living things, especially soil bacteria, fungi, or invertebrates that decompose organic material. What's it mean to be organic? Do you remember? This is from last year in chemistry. What does it mean to be organic? So in chemistry, we tend to say organic is something that is a carbon-based compound. And that's true in biology too, but in biology, we kind of lead towards saying it's organic if it comes from, is or comes from a living thing, as opposed to an inorganic thing. So organic things are what we're going to call biotic, because they come from living things or are living things. And the inorganic things we're going to say are abiotic, like a rock is abiotic, right? It's minerals and things like that. All right, so what is an organism that can produce its own food using light, water, carbon dioxide, and other chemicals? What you got, Emerson? A producer, and another way to say it is an autotroph. So here's where we get into those Greek and Latin roots. So autotroph, so auto being self, meaning it produces on its own. It doesn't have to eat something, right? And what do you think of if an autotroph is an organism that produces its own food from an energy source, then what do you think a autotroph is? Do you remember what photo means? Anybody know? Well, it's more physical science, but we said it in chemistry. No, we're here for physical, but that would be light. So a photoautotroph would be something that uses light. So a plant would be a photoautotroph. All the trees out there, photoautotrophs. And I'll give you this one. So this is when photosynthesis is going to be when energy enters the system as sunlight. So energy that enters the system out there in the little garden. My mother planted some tomato bushes this summer, right? So mom lives downstairs. She planted some tomato bushes out there, little vines, whatever you want to call them. I don't even know because they look scraggly as heck this year. You know why everything looks scraggly to me? All my bushes. Because we had that hailstorm and it beat everything to death. It beat everything to death. So we only got a few little tomatoes this year, but the energy that I get from those tomatoes came from the sun. Sunlight came in, photosynthesis went on in the cells of the tomato plant, produced a little tomato for me, and then I get a little energy if I eat the little itty bitty tomato. Better example is the fig tree in my neighbor's yard that leans into my yard survived pretty well. It was late, but in the last week or two, it's been popping out ripe figs right and left. I can't even eat them all. Like it's crazy. So what uses photosynthesis? What type of organisms? Somebody tell me. What type of organisms use photosynthesis? Animals? What uses it? Not animals. What? You girls are real quiet today. Plants and producers. Yeah. Plants and producers. That's it. Yes. Plants and producers. So other examples are plants, algae, and some types of bacteria. Okay. Now, we'll talk about this in a minute, but I want you to remember algae. We're going to be working with algae in lab today, a specific algae called Chlorella vulgaris. It's real common in ponds and things like that. If you look at pond water and it's kind of green, it's because there's algae in it. One of the most common ones is going to be Chlorella vulgaris, which is what we're going to use today. It's really cool. And we'll talk about this, but I want you to keep this in mind the whole time. When we say, sometimes people simplify it and they say plants breathe in carbon dioxide, and breathe out oxygen. They don't really breathe, but they take in carbon dioxide as part of photosynthesis and they put out oxygen as a product, right? Okay. So about, I want to say 8 or 9 years ago, there was a terrible event where a huge part of the Amazon rainforest caught fire. It was bad. Like it was all over the news. The rainforest was on fire. There was smoke. It was awful. And people were panicking because they're like, oh, that's the lungs of our planet. If we lose all these trees, we're going to lose oxygen. Most of the oxygen that we have in the air does not come from trees. It's algae. It's small little phytoplankton, little tiny organisms in the oceans that produce most of. So the lungs of our planet aren't really our biggest forests. It's our oceans. So that's why it's important to keep our oceans safe and clean, right? Because we don't want to have problems there. So does all energy come from sunlight? Yes or no? What do you think? All energy. No, Emerson says. And you're right. No, because not all producers are photosynthetic. So I gave you this word a little bit ago. It's when energy enters the system, when it's released in chemical reactions. Do you know what you call those types of organisms or that process? Do you know that process? So that process isn't photosynthesis, it's chemosynthesis. Okay, Greek and Latin roots. Here you go. Synthesize what? To create, right? Photosynthesis creates energy using light because there's photo. Chemosynthesis is going to create energy using what? Not light, but chemicals, right? Chemicals. So you got chemosynthetic organisms. And like I said, most of them live where there is no light, way at the bottom of the ocean, for example. You have some of these organisms. You girls super sleepy today. You are so quiet. You're quiet anyway, but you're more quiet than usual. I know you've got your binder work done. All right, most what? Okay, here's that word again. So chemoautotrophs. Okay, autotroph makes its own food. Photoautotroph makes its own food using light, we said. A chemoautotroph is going to make its own food using chemicals. And look at this. We call them extremophiles. Okay. Do you remember the words last year from chemistry, hydrophobic and hydrophilic? Do you remember that? Do you remember what hydrophilic meant? Do you remember what philos means? So that means loving or liking. So if you have extremophile, it likes or loves extreme conditions. So like I said, bottom of the ocean, where it's very cold, very dark, extreme. They're bacteria or archaebacteria. Sometimes you just say archa. What is archaeology? The study of what? You know? Archaeology? Is it the study of something that happened yesterday? No, it's a study of something that happened way long ago. So it's old or historical. So when you hear archaebacteria, those are like the earliest and least evolved bacteria that we have. They're the very beginning life forms. So they live in hostile environments, like we said, extremophile, such as deep sea vents, where it's really hot, right? Because you've got all that molten, earth under the crust right up against the surface, so it gets very warm down there in some places. And they are primary producers in their ecosystems, meaning they are basically like the trees and the plants are up here, and they convert inorganic carbon dioxide into carbon. That's pretty cool. So whether a photoautotroph or a chemoautotroph, all food energy in a system is going to come from what we call producers. All right. So here's some definitions. You have your notes out. So what is an organism that cannot produce on its own and instead takes nutrition from other sources of organic carbon, mainly plant or animal matter? Got a couple options that could be here. So this one's going to be heteroautotroph. Okay, a heterotroph, sorry. So troph again was your energy, right? We're going to talk about trophic levels in a minute. Troph is energy. Heterotroph. Hetero means different, right? So if you're going to get your energy from something other than yourself, from something different, you're a heterotroph. Okay, what's an organism that obtains energy from organic compounds? You know? So this one's going to be an organotroph. Okay, there's that word again. Most things are going to be organotrophs, except for some of those chemoautotrophs. Primary or secondary, tertiary consumers. What eats dead plants and dead animal material? Do you know what you call those? Girls are so quiet today. Those are our decomposers, right? Fungi, bacteria. And then bacteria and fungi, those are great examples. And then over here, what's a type of decomposer that eats lumps of dead matter? This is not going to be a mushroom or something. They grow on dead logs, but they're not going to eat lumps of dead matter. I'll give you a hint. It's going to have vor in it, like omnivore, herbivore, carnivore. So this is a fun one. Detritivore. Do you know what detritus is? Detritus is like yuck, leftover stuff. So like if you go out into the forest floor and you pick a clear spot and you see just little granular mess, just whatever thing, that stuff that's starting to decompose, but it's just in little granules or whatever, that's detritus. You can use detritus to describe a lot of things too. People will like say you go into like a house of somebody that maybe somebody was like a hoarder and they died in their house, and you know, you'll see one of those documentaries on TV and there was detritus everywhere, like there was just stuff, dirt and gross stuff growing everywhere. That's detritus. And then what do you call a type of composer that eats decaying organisms or dead animals? You know this one. Like a vulture, for example. What eats dead animals? What do you call those? What do you call it, Everly? You know it. What is that? Starts with an S. Do you know it, Emerson? Scavenger. There you go. All right. So our big scavengers around here that you can see at work are those turkey vultures. Yeah, seen them? They creep me out because they have no feathers on their heads, and there's a good reason for that. They have no feathers on their heads because they're sticking their heads in dead animal carcasses, and they don't want to get dead animal juice all over their feathers. Ew. So they have little bald heads. You know what I mean? They're great. They're fabulous. Like, thank God we have them because they're necessary, but boy, are they unattractive. And if you ever see like a dead deer on the side of the road and you see them at work, 24 hours, they'll have it down to a skeleton, less than 24 hours. Another one that you can see working in your yard is yellow jackets. You ever seen yellow jackets take apart something? Yeah, you've seen it? Yeah, I had a little snake, a little tiny, like a Decay's brown snake, like this long, maybe as big as my pinky, died in my yard once. And I left it to see what happened. And because I was wondering what was going to eat it, like ants or something will come eat it. Mostly it was those yellow jackets. They ate that thing. Within 24 hours, it was a skeleton. I was impressed. I was like, that is seriously good work there. Whoops. So decomposers return raw material to the environment. All right. So consumers. What's an organism that cannot produce its own food, instead taking nutrition from other sources of organic carbon, like plant or animal matter? This would describe you. So this one's going to be heterotroph again. We talked about that, heterotroph. So you get your energy from something else. So you're a heterotroph, right? Trees would be autotrophs. Tomato plant is an autotroph. I eat it, therefore I'm a heterotroph, right? All right, what do you call an organism that obtains its energy from organic compounds? We kind of said this one. So that's an organotroph, okay? So we can have organotrophs in the consumer category. We can have organotrophs in the decomposer category, right? Because decomposers are a type of, sort of like a type of consumer. So if you look here, types of consumers are big ones are herbivores, omnivores, carnivores, scavengers. So herbivores eat plants, right? Carnivores eat animals. Omnivores eat both. And scavengers eat decaying dead organisms like the vultures. Okay, give me an example of an herbivore. Somebody give me one. What's an herbivore? An animal that eats only plants.
No.
Oh, come on. This is an easy question.
Yeah.
Levi, do you know any? No? Okay. Did you have milk with breakfast? No? Yes? Everly? Where'd it come from? Where'd it come from? A cow? Maybe a goat? Something like that? Okay. What do they eat? Grass all day. So they are going to be your herbivores. A carnivore. What's a good example of a carnivore? Can you think of one? These guys are always at the top of the food chain. So these are predators. So what's a predator that you can think of? What you think? Good.
The first one I thought of was not deer.
Was not deer? Yeah, not deer. You're correct. Not deer. Deer are going to be herbivores, right? They're out there eating privet in my woods and all, and coming into my yard and eating my garden and my flowers and all that. Yeah, they're real fun. What do you think though about deer's biggest predator around here are going to be us and one other animal that's a canine that I can think of.
What eats the deer?
What eats the deer? What canine around here? They're about this big. There used to be one on TV that ran from a road runner all the time. Coyotes. Coyotes are a good example, right? Okay. And omnivores. Okay. Here's a good question. What are you? A carnivore, an omnivore, an herbivore. What are we? An omnivore. How do you know? Say you found, remove yourself from being a human. You found a human skull on the ground and you looked at that human skull. How would you know that's an omnivore? Why do you think? Teeth. You look at a dog's teeth, they've got some molars in the back, but they've got real big canines, right? And that's for like ripping and shredding and pulling meat off of an animal that they've captured and killed. We've got little canines and then these nice big incisors in the front that are for, biting into an apple, right? So there are a lot of people who will swear up and down that we should all be vegetarian, and that's great if you want to be vegetarian. There's plenty of ways to go about it now. But biologically speaking, you're meant to be an omnivore because you can tell by your teeth. All right, let's see what's next. So we have food chains and food webs. All right, these are pretty easy to understand. The chain is literally a step by step by step by step. And see where it says trophic? Remember that means energy. So we have a trophic level. Primary producers, and then what we're going to call primary consumers. Those eat from the primary producers. Then you've got secondary consumers. And they got carnivores in there. You can have omnivores at this point too. But those are going to eat your primary consumers. And then you got tertiary And this is the thing you got to remember is it only gets a little confusing when you look at the way it's worded. So first is primary producer, but second is primary consumer. So you think primary, you think first, right? But it's second because it's consumer, right? So it's your first level of consumer, but it's your second energy level. So then tertiary means third. That's what tertiary means. So your third level of consumer, which is your fourth energy level, they're going to be carnivores. And then look at the tippy top, you've got the hawk that catches the snake, right? So that hawk doesn't really have too many predators, does he? He's at the tippy top, right? But a food web is a little better explanation of how energy flows in systems because it's not step by step. It shows interactions and relationships in a system. This rabbit, okay, the rabbit eats the grass, the rabbit's eaten by the owl. Is the owl the only thing that eats the rabbit? No, the fox eats the rabbit, the hawk eats the rabbit, the mouse eats the grasshopper, but look, the mouse can be eaten by the fox or the owl or the hawk. So it's not so linear. It's more of a jungle, but it's a better explanation of how it works. There's interdependence and interactions between different organisms. So it acknowledges that an organism can play more than one role in a food web. And most webs only have 3 or 4 feeding levels, which is kind of what we have over here. We've got 5, so not too far out, right? All right, now trophic flow. Trophic means what again? Energy. So how does the energy flow? So the most energy is in the widest part of the triangle. So that's your grass, right? Your plants. Then your second highest level of energy is in your primary consumers. Remember, those are your herbivores that eat, your primary producers. Your third level, your secondary consumers are going to have a little less energy. And then by the time you get to the top, where you've got tertiary consumers or your top tier predators, they're going to have even less energy. Look at every one of these where it says energy lost. Where's the energy going? So we have a law of conservation of energy. So it's not really lost. So that's a clue. You can make an inference. There's that word. You can make an inference based on knowing that energy is conserved, but it's obviously an open system, right? It's not a closed system. It's an environment. So it's not a closed system. So the energy isn't lost. What do you think happens to that energy where it says lost? In quotes even. Where do you think it happens? Let me ask you this. If you touch a bunny, describe to me how it feels to pet a bunny. How does a bunny feel when you pet him? Fluffy. What else does he feel like? Is he cold? Is he warm? Is the bunny warm? When you touch a bunny, is it warm? If you pet your puppy, is your puppy warm? If I pet Ozzy, Ozzy's very warm, right? What's happening to that energy? It's being lost as heat, right? That's why when y'all leave here, I crank down the AC like for the 3rd time in the morning because all y'all's little bodies running around in here make it real hot, right? So the energy isn't lost. It's converted to heat, which is part of the aerobic respiration. It's the opposite of photosynthesis that's going on in our cells. And energy is released as heat. So it's just released into the environment is really all it is. But it's not really lost. All right, so then your most energy is available at your producer level. And here's an example. So kilocalories, 10,000 kilocalories here. Heat loss, there it is, 1,000 kilocalories, 100 kilocalories, and then 10 kilocalories. So these guys down here, like this bunny, for example, and eats this grass, this bunny gets, a fair amount of energy from it, but then the snake gets the energy from the grass on its way through the bunny, right? And then this guy up here, this eagle, is going to get his energy from the snake who got his energy from the rabbit who got its energy from the grass, right? So there are fewer organisms at the top because the energy is limited. Are there more little blades of grass or more eagles? There's far more grass, right? Are there more trees than there are coyotes? Yes, because there's more energy at the bottom level, right? So that's what we're saying. All right, let's see. So now we're going to talk about cycles. Some of these cycles you already know. Some of these cycles, I don't want you to spend too much time on it. It's more for the lab rats level kids, but know about them. So remember that matter is anything that has mass and takes up space. So these are cycles of matter. Matter is going to be composed of atoms. This is one question a couple people missed on the test, but I had a question about two different atoms combined to form a what? A compound, not a molecule, because a molecule, one, it implies it's covalently bonded, but two, remember, oxygen never goes around by himself. He's always holding hands with another oxygen. So O2 is a molecule, not a compound, because it's two oxygens. But H2O is a compound because now you have oxygens with a different type of atom, right? There's a hydrogen jumped in there. All right, so two or more atoms joined together called a compound, not necessarily a molecule. And important cycles of matter include water cycle, carbon cycle, nitrogen cycle, phosphorus cycle, and oxygen cycle. Did you know all these things are going around all the time? This is constant, right? This is part of our environment. We don't even think about it because it happens all the time. So the water cycle, you've seen this before and you know it. This is a far more complex version than the little one that you're used to that just has like clouds, precipitation, right? This is pretty involved, but it includes things like dew. And the one thing it didn't really show in here that I kind of wish it did is there is water that is released by plants in transpiration, which we'll talk about later this year. But plants do release water into the environment. That's why if you don't water your plant, sooner or later it's going to die, right? Because it does lose water through its leaves. So water is released into the environment through plants. So, all right, this one's easy. Water evaporates, it forms clouds. Then what happens? What do the clouds do? What do the clouds do? Everly, what do the clouds do? They get all gray and dark, and then what? It rains, you get precipitation. So that can be rain, sleet, snow, or hail, blessed hail that destroyed everything and got me a new roof. Nothing like buying a new roof because you buy this roof and you're like, that was expensive and nobody can tell.
Nothing.
You get no upgrade. You're not like, I'm loving my new kitchen. Nope. It's just, there's a roof. But hey, it wasn't even big hail, it was little hail, but it was about 20 minutes, which is the longest hailstorm I've ever seen. Then what happens to the hail? How does it get back up? What happens? You know this. It runs off, it becomes groundwater or lake water or pond water or river water. We got aquifers under the ground. That's all next year. We talk about that a lot in earth science. But that's a very basic version of your water cycle. And remember, your water is essential for life. Now let's look at this carbon cycle and nitrogen cycle. So consumers take in oxygen for their life processes. Consumers release carbon dioxide as a waste product. So there is there's oxygen coming out of this tree because, like I said, plants are going to release oxygen, and there's oxygen coming out of the grass, right? Now, this is interesting because this little pony here, he's breathing in that oxygen, and he is exhaling carbon dioxide, right? But he's also eating carbon because there's carbon in that tree, in the grass too. So remember that. So he's going to exhale that carbon dioxide. And then what's the tree going to do with the carbon dioxide? Take it in because carbon dioxide is part of the photosynthetic process, which we'll talk more about. So most organisms use nitrogen that has been fixed by bacteria in the soil. Okay, so plants need nitrogen, but they can only use it in a certain way. So most of the air around us is nitrogen. There's more nitrogen than there is oxygen or carbon dioxide. You breathe in and out nitrogen all day long. Your body can't use it. You breathe it in, you breathe it right out. You're not using it at all. But you get nitrogen that has been fixed in the soil through certain bacteria. So the bacteria undergo a certain process, and that kind of makes the nitrogen into a form that you can use. All right, so here's a real quick video. It's only 3 minutes to see if we get a stupid commercial. No, we don't. Good. Okay.
The sustainability of our world depends on nutrients and the way they cycle through the environment. carbon, nitrogen and phosphorus cycles are all pivotal in providing food, timber, fibres and fuels. They regulate our climate, protect human health, and are an important driver of changes in biodiversity. Through industrialization, agricultural intensification, and urbanization, we have altered these cycles. For example, the use of inorganic fertilizers containing nitrogen and phosphorus increases crop yield, but cropping diverts carbon away from the soil. And overuse of fertilizers can lead to enrichment of nitrogen and phosphorus, with knock-on effects for biodiversity and water quality. It is important we understand carbon, nitrogen, and phosphorus cycles, so we can, in turn, understand the consequences of human interventions. However, these cycles are complex. They span the Earth, from the atmosphere through to plants, soils, and water. And the cycling of the elements themselves are interlinked through biological processes. Living organisms need carbon, nitrogen, and phosphorus in relatively fixed proportions. And so, life on Earth closely links the cycling of these three elements. For example, plants attain the carbon they need from the atmosphere via photosynthesis, but it is often the amount of nitrogen and phosphorus available in the soil that determines their growth. Nitrogen is abundant in the atmosphere, but most plants can't access this. They need bacteria that live in the soil to convert this atmospheric nitrogen to forms that plants can use. The ability of bacteria to do this is dependent upon the availability of phosphorus in the soil, which in turn comes from the weathering of rocks, weathering that can be accelerated by plant and fungi activity. And so the amount of carbon entering plants is regulated by the amount of nitrogen processed by bacteria, which is related to the amount of phosphorus. And this is just one set of relatives of the elements. That is why, in the long-term, large-scale macronutrient cycles project, we're developing computer models that link carbon, nitrogen, and phosphorus cycles, linking scientific disciplines and linking people to improve our understanding of nutrient cycling change and its consequences, to help work towards a more sustainable future.
So you've got phosphorus that comes from weathered rocks, right? So rain, wind, water, weathered rocks, and that releases some phosphorus down into the soil. And then you've got bacteria in there that use the phosphorus to fix, it's called fix the nitrogen into a form that the plants can use. And then the plants are going to produce oxygen. So everything is linked. Now, go to the next, nope, go. In our lab today, you're going to be using a nitrogen-rich fertilizer, and you're going to see how that impacts the growth of your algae. So what do you think? Let's hypothesis time. You're going to do this with your lab too, but just to practice. What do you think will happen if you add more, and it's already it's already in its usable form. So if you add usable nitrogen to a sample of algae that's living in water, what do you think is going to happen? Do you think you're going to get more or less algae? What do you think? Emerson, what do you think is going to happen? You put give it more food, basically, what's going to happen? It's going to grow more, right? That would be a good hypothesis. So here's why that matters. Nobody's fertilizing their ponds. Okay, we don't go around fertilizing ponds to grow more algae on purpose. That's just not what we do. But what is happening is people fertilize their farms, their yards, their gardens, and then we talked about the water cycle. Rain comes down, washes all that away, and it ends up in rivers, lakes, streams, ponds. And ponds, especially and lakes, because the water's not moving like it is in a river or a stream, you get algae growth, and you can get a lot of algae growth, right? And it gets a little crazy sometimes. My grandparents had a pond, and I'll tell everybody this with lab again, but my grandparents had a pond that was half theirs and half their neighbors. The property line went right down the middle. And in the spring, they would get so much algae that you could lift it up with a stick. It was like a blanket. It was like this thick. And they were always like, oh, the slime's back on the pond. And boy, was it. It was wild. It would cover the whole pond. It was crazy. All right, so we're back in our normal routine. So this is going to be your first homework assignment, right? So that's going to be in Teacher Ease. So Teacher Ease is the online platform that we use. Everybody has a login, everybody has an account. And I put a lot of assignments in there. It's also where you can see your grades. Everything's always in there. You know what's going on. All your grades are in there. At any point, you can go, that's my average. This is my test. This is how I did. This is what I missed. This is what I got right. All right there. And we do homework almost always in Teacher Ease. Sometimes we'll do it on paper. Labs are the thing we do most on paper. We do most everything else, most of our other assignments through Teacher Ease. Now, when it comes to midterms and finals, we do those on paper in class. So I let everybody do their other tests and stuff. That's all at home, outside of class, because we meet once a week. And this is what our time is for. It's not for sitting there and taking a test. You can do that whenever. But midterms and finals, we do in person, and they feel higher stakes. They are percentage wise, but they feel very different than every other class. You come in, everybody's quiet, aren't they? Aren't they, Colin? Yeah. You come in, it's weird. It's like, this is not what I'm used to. And everybody has their little pencil and they go to their little spot. And I had one kid who sat on the floor last year, and that's absolutely fine if that's where you're comfortable. I don't care. But it feels high pressure. It feels different. I want it to, because you're going to have to do that at some point in your life. So it's good to practice it in a place you know you're safe and loved, and your friends are here, and everybody else is doing the same thing, you know, and everybody else is, you know, turning off their phone and sitting there and feeling strange. And that's the point. It's supposed to feel foreign. It's not supposed to feel like what you do every week.
Right.
So the homework, you'll go into Teacher Ease. You girls know this, but you'll go into Teacher Ease. You'll open up the assignment. Some of these biology assignments, just so you know, I said this at the grilling show, but I'm reminding everybody, they're not like the chem assignments had like 3 questions, right? It was usually like 3 questions or 4 questions, and that was it. Some of the biology ones have more questions, but they're worth less. It's still going to be 5 points. But they'll be like, this one's 0.25, 0.25, 0.25, 0.25. That's 4 where you would have had 1, right? So we do that a little more in biology, just because there's a little, I want to kind of cover things a little differently. So be aware of that. Now, also in Teacher Ease, there's always the first question, which has nothing to do with the rest of the, there's usually 5 questions. So one, and sometimes there's 3 because there's worth 2 or whatever. The first question is worth nothing, really. It's worth 1 point, but what it is it's my reminder to think back to class and see, did you answer questions? Because if you did, you're going to get credit for doing your binder work. So that's where I give you credit for that. So if you never speak and you sit there and you're zoned out, I'm like, they probably didn't go ahead and do that work before class because they don't have a clue what's going on. So you're going to not get credit, and it'll be a silly question. Like, does pineapple belong on pizza? What's your most used emoji? It's got nothing to do with the lesson. It's to trigger me to go, when I grade it, did that person do the work?
Right.
So that's what that's for. Okay, so now what we're going to do is I'm going to turn off my recording for today for this class. That will be uploaded to Zoom. So at any point, you can go back and watch it. And if you're absent, like Evan is absent today, Evan can go back and watch the class. And that's how you get your class participation credit, is you comment on the video in YouTube. You say,